Okay, today we're going to do practice E, which is perfectly inelastic collisions. Now, when we talked about collisions, we say that we do something called conservation of momentum. And conservation of momentum said the total momentum before is equal to the total momentum after. And we can have different types of collisions. So one type is elastic, and elastic is where they bounce off each other, and they each move off with their own velocity. Today we're doing inelastic. So inelastic is where they collide, and they stick together, and they move off together with one velocity. So what we said yesterday was when we have our main equation, the total momentum before is equal to the total after. And we said the total is the sum of A plus B is equal to A plus B after, but to distinguish before and after the collision, what I do is I just call this prime, so I don't have to do that double subscript. And then we know that momentum is mass times velocity, so momentum before would be MAVA plus MBVB. Now, after collision, if I wrote it like this, MAVA prime plus MBVB prime, this VA prime and VB prime, this is the same velocity. So because it's the same, I can just call it V prime because they're stuck together. But then to simplify this, I can just say MA plus MB times V prime. So this is the actual equation for inelastic where they stick together. You know, someone said to me, these equations are so long and there's so many to memorize. I said, it's just a concept. The total momentum before is the total after. So you know that if they stick together, they have one velocity, and that's it. So the total mass together is moving off with one velocity, and that's it. So now we're going to read our problem. We'll do number 1. And it says, a 15-kilogram car. So when I'm reading the problem, again, I want to chunk it. I don't want to just kind of read the whole problem and start to get confused. I mean, of course, I want to read the whole problem at first to know what type of problem it is, but then I'm going to read each little variable. A 15-kilogram car, so I'm going to call that MA, 1500, is traveling at 15 meters per second, and there's a typo, that should be south. Now, this is where, remember, momentum is a vector quantity. It has both magnitude and direction. You have to be consistent with your sign convention. So we'll use our standard Cartesian sign convention that up and to the right is positive. So I'm going to call north positive and east positive, and then I'm going to call south and west, I'm going to call those negative. Okay? So we're just going to stick with our standard Cartesian sign convention because geographic directions go north, south, east, west. So we'll just correlate those to our regular standard Cartesian sign convention. Up and to the right is positive. All right. So because it says it's traveling 15 meters per second south, I'm going to call that velocity negative. And it's negative because it's south, and I'm calling north positive. It collides with a 1,500-kilogram truck, so I'm going to call that MB 4,500, which is initially at rest. So the velocity of this is equal to 0 because it's stationary. The car and truck stick together and move off after a collision. So they stick, so I know when they stick, there's just going to be one velocity. What is the final velocity? So I want to find V prime. So here's my basic equation, MAVA plus MBVB. So this is the momentum of each vehicle before collision, and then this is the momentum of the combined mass after collision, and it says to find VB prime. Now instead of just plugging my numbers in, I'm going to rearrange my equation to solve for the unknown and in terms of known. So because this is a parentheses, all I'm going to do is take this whole quantity and divide it here. So I'll rewrite it MAVA plus MBVB divided by MA plus MB is equal to V prime. Now I'll go ahead and substitute in my values. So V prime is going to be 1,500 kilograms times negative 15 meters per second plus 0. Because this is stationary, the whole term goes to 0, so I can just get rid of that. Divided by 1,500 plus 4,500. So when I work all that out, it comes out to be negative 3.75 meters per second, and then my final answer would be negative 3.8, because this negative 3.8 meters per second, or let me just cross this out and say V prime is 3.8 meters per second south. So the negative means it's going opposite the direction that I'm calling positive, which is north. So my final answer would be 3.8 meters per second south. And that's it. So all the problems in practice E are perfectly inelastic. So that means whatever momentum car A loses, the other one gains, but these are stuck together. These are stuck together, so they move off with the same velocity.